All right, trigonometry here. This is a video over the sum and difference formulas, the last major topic here before we have our big trig test. Now, I want to let you guys know ahead of time this video is kind of long. It's not, where it's points can take you hours, okay? But if you want to space it out, do half of it, and then, spend 15 minutes, then another 15 minutes a little bit later on. It is a little bit over half an hour long, but it really is going to help you understand this topic, especially since I mentioned I won't be in class one day next week. All right, so we have the sum and difference formulas, and they are when you're adding inside of sine, cosine, or tangent, or subtracting, obviously sum and difference. Now, the key thing I want you to understand is some kids think that you could distribute sine like it's a number, like sine. Like if I do sine of u plus v, that's sine of u plus sine of v. Well, that's not true. It's not a number that can be distributed, but we do have these sum and difference formulas to help us do the problems. So u and v represent angles. Okay, they just represent angles. So notice the formula here for sine says if you're adding the angles, that's why the plus sign's on top, or subtracting, then here's the formula. Sine of the first angle, cosine of the second angle, plus if you're adding, minus if you're subtracting, cosine of the other angle, u, sine of the other angle, v. So notice if you're looking at these two things, we got sine of u in the front, sine of v in the back, cosine of v in the front, cosine of u in the back. So it does switch who gets the u and who gets the v. For cosine of addition or subtraction, notice there is a slight change here. But if you have cosine of u plus cosine of v or cosine of u minus cosine of v, you have cosine u, cosine v. So rather than alternate like sine, it goes cosine, cosine. If you're adding with cosine, you use a minus sign, and then sine u, sine v. If you're subtracting with cosine, you then use a plus sign. So if cosine v, or cosine u, cosine v plus sine u, sine v. So cosine works a little bit different. If it's a plus sign, the formula actually utilizes a minus sign. If it's a minus, it actually utilizes a plus. So it's kind of opposite there. When you're working with tangent of u plus or minus v, we got tangent of u plus tangent of v on top, and then we got a fraction. On the bottom, we got 1 minus tangent u, tangent v. So if we're working with addition, you have addition on top, but subtraction on the bottom. If you're working with subtraction, on top you have tangent u minus tangent v. On the bottom you have 1 plus tangent u, tangent v. So these are the formulas you have. Notice how you have the plus or minus, then what it goes over in the formula. For cosine it switches, and for tangent switches on the bottom. So let me just kind of do a quick run through of an example here for you. If I have sine of a minus b, that would be sine of the first angle a, cosine of the second angle b, minus, sine does what it says, sine of the other angle b, cosine of the other angle a. Now you may say, well, that's not exactly what the formula looks like. Yeah, it's multiplication, so the order that you multiply the back to doesn't really matter. But the key thing is I have sine a in the front, sine b in the back, cosine b in the front, cosine a in the back. If I have cosine of x plus w, that would be cosine of x, cosine of w, slightly different formula. It's a plus sign, so I do end up using a minus sign. That's why cosine is a little bit weird. And then I do sine of x, sine of w. Okay? So let's go to our worksheet here. So make sure you have your cheat sheet out, your unit circle out, and your worksheet out, because we're going to do some of those problems. So you want to pause and grab that stuff. But anyway, here was the first problem. And basically, sine of 285 is an angle that we don't know. We want to find the exact value of this, but the problem is it's not on our unit circle. But the goal here is to find two angles that add or subtract, sum or difference, to get 285. And we want to use angles that we do know on our unit circle. There are several different combinations that you can use here. I'm going to utilize the fact that 285 degrees is 150 plus 135. Now there are many different combinations. There's even some where you could use subtraction, but I just chose to use this, okay? But any of the combinations will result in the same answer at the very end. So now I'm going to utilize my sign of addition. So I'm going to do, now why? Again, I want to emphasize why, because I know these two angles. They're on my unit circle, whereas 285 is not. So I'm going to do sine of the first, 150, times cosine of the second, 135. And it's a plus sign. Sine does what it says. And then I have sine of the other angle, which was 135, times cosine of the first angle, which was 150. Okay? So now I'm actually going to go to my unit circle now. Sine of 150 degrees is 1/2 times cosine of 135 degrees is negative radical 2 over 2. Sine of 135 is radical 2 over 2. Cosine of 150 degrees is negative radical 3 over 2. Make sure you multiply before you add. That's going to be negative radical 2 on top over 4 plus negative radical 6 on top over 4. You are allowed to multiply radicals as long as they're both in radicals. So 2 times 3 doesn't make the 6. And then when I combine this, I get radical 2. I'm going to go ahead and say a plus, a negative is just a minus. Radical 6, and I already had a common denominator, so I'm going to make one denominator of 4. So this would be my exact answer for sine of 285 degrees. If you want to check it, go ahead and put yourself in degree mode. Type in sine of 285 degrees. You're going to get a weird decimal. And then confirm that negative radical 2 minus radical 6 divided by 4 is that same value. Let's try another one, but this time in radians. Again, 5 pi over 12 is not on my unit circle, but I need to somehow combine two angles that are on my unit circle to make 5 pi over 12. There are many, many different ways to do it. A lot of kids struggle with this because it is fractions, but if you work hard at it, you will be able to figure it out. It is 3 pi over 4 minus pi over 3. There are other ways to do it, though. Again, if I would get a common denominator, that would be 9 pi over 12. Minus 4 pi over 12, and 9 pi minus 4 pi would make the 5 pi over 12. Why am I choosing these angles? Because they're angles I know from the unit circle. So I get cosine of 3 pi over 4. I'm now utilizing the cosine formula times cosine of pi over 3, slightly different formula. It's a minus sign, but I need a plus sign. And that's going to be sine of 3 pi over 4 times sine of pi over 3. Again, utilize the formula for cosine. Cosine of 3 pi over 4 is radical 2 over 2. Oh, I believe it's negative radical 2 over 2, sorry. Times cosine of pi over 3 is 1/2. Plus sine of 3 pi over 4 is radical 2 over 2. Times pi over 3, sine of pi over 3 is radical 3 over 2. So I get negative radical 2 over 4 plus radical 6 over 4, which gives me a final answer of negative radical 2 plus radical 6 all over 4. Now you may say, wait a minute, that is very similar to the previous answer. It is very similar. It's not exactly the same, but very similar. And you are going to see a lot of similar answers only because if you look at the unit circle, you have a lot of radical 2s, a lot of radical 3s, a lot of 1/2s, a lot of 1s, a lot of 0s, a lot of 2s, and so forth. So when you multiply, you do get answers that do look very similar, but yet, because of negatives and positives, are slightly different. Let's try another one here, tangent of 105 degrees, just so you can see how tangent works. Again, I don't know 105 degrees, it's not on my unit circle, but I am going to find a way to create it using angles that are on my unit circle. Again, you could use addition or subtraction. It does not matter. All the ways should lead to the same answer. I'm going to do tangent of 60 plus 45. 60 plus 45 are angles that I do know, and they add up to 105. So the formula for tangent is tangent of the first plus tangent of the second. 45 degrees. And then on the bottom, it's actually 1 minus, it was a plus sign, so we're going to use a minus sign, tangent of 60 degrees times tangent of 45 degrees. So tangent of 60 degrees, I believe, if you're looking at your unit circle, 60 degrees, tangent, I believe, is radical 3. Plus tangent of 45 degrees is 1. That worked out nice. On the bottom, I have 1 minus, tangent of 60 degrees is radical 3, times tangent of 45 degrees is 1. Do that multiplication first on the bottom, so make sure you do multiply first. Radical 3 times 1 is radical 3, so I get 1 minus radical 3. Now I'm going to leave that as my final nice answer. I know that we do have a radical on the bottom, but it's combined with 1 minus radical 3. If you really don't like it down there, you would multiply by the conjugate, 1 plus radical 3, but it's not really that pretty, so we'll just leave it like that. Okay, so that is how you deal with it in basic terms. Now let's move on and let's use that formula, or the three formulas. Let's use them in reverse. Notice here we have the formulas on the right hand side. We're going to try to condense them down to write them as just a singular sine, cosine, or tangent. So if I'm looking at these, notice I don't know sine of 140 degrees. I don't. It's not on my unit circle. Cosine of 50 degrees. I don't know it. It's not on my unit circle. But notice that I could utilize the formula. I do notice this is the sine formula. How do I know it's the sine formula? Because it goes sine, cosine, as opposed to the cosine formula goes cosine, cosine, sine, sine. So I know that this is the sine formula, and I know that's the sine formula of addition. Why? Because the sine formula does exactly what it says. It says addition, so the sine formula holds true to what it says. So that would be sine of 140 degrees plus 50 degrees. And again, if you don't believe me, utilize the formula, and you will see that that is what you get. Now I can actually go and add those together, so that is sine of 190 degrees. So basically I'm just using the formula in reverse. Let's try it down here. This is cosine, cosine, sine, sine. That is an obvious cosine formula because of the cosine, cosine, sine, sine. And it's actually subtraction because remember, with cosine it's the opposite of what it says. It says plus, it's going to be subtraction. So it'd be 65 minus 25. And 65 minus 25 is 40 degrees. So that would be cosine of 40 degrees. Okay. All right, let's try a couple more like this one. Here's one with tangent. Once again, pretty obvious that it's tangent. Don't think I need to explain why it's tangent. And it's tangent of subtraction because it comes from right here. The bottom is the opposite of what it is, so it should be subtraction. So it holds true to whatever the top is. The top says minus, it's going to be minus. And the two angles are 5 pi over 4 and 1 pi over 12. Now, if you could do that in your head, you should be able to get a common denominator, add these together. That's going to be 15 twelfths pi minus 1 twelfths, 15 twelfths minus 1 twelfths is 14 twelfths pi, 14 twelfths pi. But that does reduce to, oh, wait a minute, did I do that right? I feel like I made a mistake there. 5 fourths minus 1 twelfth. Is, or should be 7 pi over 6. Yes, so that would be 7. I'm sorry, you're right. That does reduce to 7 pi over 6. Once again, 5 fourths minus pi over 12. That does work out to 14 twelfths, 7 pi over 6. And you could leave it like that, but I actually know what tangent of 7 pi over 6 is. Tangent of 7 pi over 6, because 7 pi over 6 is on my unit circle, is negative radical 3 over 3. Oh, I'm sorry, no, positive radical 3 over 3. All right, so hopefully that makes sense. Let's do one more. I believe there's one more in your notes here. Here we go. If I said, hey, is this sine, cosine, or tangent formula? I'm pretty sure you would throw tangent out the window. This is the cosine formula because I see cosine, cosine, sine, sine. So again, what I'm going to do here is I'm going to know that it's plus because it says minus, and cosine lies. It's the opposite of what it says. And it'd be 45 plus 120, and that would be cosine of 165 degrees, which I don't know because it's not an exact value from the unit circle. But think about 45 and 120 are. So you could have went from the very beginning, you could have said, oh, I know cosine of 45 degrees. That's radical 2 over 2. I know cosine of 120 degrees is negative 1/2. Oh, I know sine of 45 degrees is radical 2 over 2. I know sine of 120 degrees is radical 3 over 2. And you end up getting negative radical 2 minus radical 6 all over 4. You can do it that way as well. All right, so what I want to do next is shift gears a little bit here and talk about inverse trig functions. Now, you may say, well, what are you talking about inverse trig functions for? Because it's going to actually help us with the next set of problems, if you notice. Now, the key thing I want you to remember is inverse trig functions equal angles. Inverse trig functions are angles. So, if, like, for example, if we had sine of x, an angle, equals 0.3, we would say inverse sine of 0.3 equals x. So inverses do equal angles. That's the key thing I want you to realize. Inverses do equal angles. So let's say, for example, I said that I'm going to give you this value right here. Cosine inverse is 2/5, or cosine inverse of 2/5. Now you would say, well, inverses equal angles. This angle would be, you could use your calculator to find it, obviously, but I'm just going to say that let's call it alpha. Or theta, it's called theta. So remember, you could draw a picture of theta. So let's draw a picture of it. Here we go. Here's theta right here. I know in terms of right triangles, cosine is adjacent over hypotenuse. So 2/5, right? 2/5, adjacent, 5, right? So that's very helpful right there. What is that missing side? Well, I would say 5 squared, the hypotenuse, equals 2 squared. Plus, I'll call it b squared. That's 25 equals 4 plus b squared. Subtract the 4 over, that's 21 equals b squared, square root, square root. So this missing side would be 21. Now, why is this kind of cool? Because based on, very little thing given to me, I mean, this was not a major deal, it was a very small thing that was given to me, I can actually do a whole lot of stuff. I can now say, hey, I know what sine of theta is. Sine of theta is radical 21 over 5. Huh, pretty cool, I know that. I know what tangent of theta is. Don't worry, I know it. I know tangent of theta is radical 21 over 2, opposite over adjacent. So you could actually use these simple trig functions, these inverse trig functions, to help you draw triangles and find a whole lot of stuff. So let's kind of shift gears and look at a different type of problem that we're going to get into next. So let's say that I told you sine inverse of 2x. Okay, now, well, I don't know what x is, but let's learn what I can do with this. First off, inverse is equal in angle, so this is some angle alpha. Let me draw a picture of this angle alpha. There it is right there. And I know sine is opposite over hypotenuse. Well, I could make this a fraction. It's over 1, right? So that means the hypotenuse is 1. So now I could actually go ahead and find the missing side here. So I know that 1 squared equals 2x squared plus a squared. Call this missing side here a. So that's 1 equals 4x squared plus a squared. So let me subtract that 4x squared over. I'm trying to solve for a squared, remember? And I could square root. So I get that the square root of 1 minus 4x squared, there's nothing you can do with that. It's just going to have to stay as ugly as it is a. So this missing side right here is the square root of 1 minus 4x squared. So from that, I could ask you all sorts of questions. I could say, hey, just out of curiosity, what's tangent? What is tangent of alpha? Oh, okay, that's opposite 2x over adjacent the square root of 1 minus 4x squared. So as ugly as that is, that's what it is. That's tangent of things. So very useful thing here. So now what are we getting at? Well, we're trying to get to be able to solve a problem like this. So let's check this problem out. First off, we have sine of an inverse minus an inverse. Now remember, inverses are angles. So how about we just let this tangent, inverse tangent of 2x, let's call that theta. And then this other one back here, cosine of inverse cosine of x, let's call that alpha. So what I essentially have is I have sine of theta minus alpha. That would be using the formula for subtraction. That would be sine of theta times cosine of alpha minus, sine holds true to what it says, sine of alpha cosine of theta. Now, I have no idea what x is, and that's okay, because I want to write this in terms of x. That's actually the directions to write that in terms of x. So I got to do a little bit of side work here. Let me draw a picture of theta. So here's theta right here. Let me draw a picture of it. And I know, according to tangent, that theta would be 2x over 1. Opposite over adjacent. That would be 2x. I could put that over 1. So it would be 2x over 1. Opposite over adjacent. So let me actually find this missing side here. So the hypotenuse squared would be 2x squared plus 1 squared. Man, my writing's bad there. So I get c squared equals 4x squared plus 1. Square root. So this missing side right here would be the square root of, I'm trying to write crooked here and it's not working out too well, 4x squared plus 1. So that missing side is the square root of 4x squared plus 1. That's very helpful. Let's do the same thing again now with alpha. Let's draw a picture of alpha. So here we go. Drawing a picture of alpha. There it is. According to cosine, that is adjacent x over hypotenuse 1. Remember that x could be x over 1, adjacent over hypotenuse. So let's see what this missing side is. 1 squared equals x squared plus b squared. That's 1 minus x squared equals b squared. Square root. So this missing side right here is 1 minus x squared with the square root. Now, based on all this information, I could come back here and find everything I need. Sine of theta. There's theta. Sine is 2x, opposite, over hypotenuse, which is pretty ugly, but the square root of 4x squared plus 1. Times cosine of alpha. Okay, here's alpha. Cosine is adjacent over hypotenuse, x over 1. Minus sine of alpha. Let's go back down here to alpha. Sine is the opposite, square root of 1 minus x squared, divided by the hypotenuse 1, times cosine of theta. Let's go back here to cosine of theta. Cosine is adjacent 1, over the square root of 4x squared plus 1. Now, when I multiply these, I will get a common denominator, which is awesome. So on top, I get 2x squared minus the square root of 1 minus x squared. Very ugly, and then the bottom would be that common denominator, which would be 4x squared, square root of 4x squared plus 1. Now, very ugly answer. I get that. I understand that. But the cool thing is, what we did was we were able to write what this is, this whole trig thing right here, we were able to write it in terms of x, which is what we wanted to do. So now if somebody told us that x was, I don't know, 0.3, I could certainly plug in 0.3 for x and solve for the problem. All right, enough of that. A lot of kids hate that aspect of it, but, watch that over a couple times. It is pretty cool. All right, verifying. We could use these formulas to verify. So remember, when we verify, we want to start with the left-hand side and make it look like the right. So I'm going to use the sine of subtraction formula. That is sine of x times cosine of 3 pi over 2. Minus, sine does what it says, minus sine of 3 pi over 2 times cosine of x. Now, watch how cool this works out. What is cosine of 3 pi over 2? Guess what? Check out your unit circle. It's a big fat 0. Minus, what is sine of 3 pi over 2? Check it out. Unit circle. It's negative 1. Times cosine of x. Now, I have no idea what x is. I don't, but I know 0 times anything is 0. Wipes all that out. Negative and a negative make a positive. Cosine of x. There's my final answer. Hey, that's exactly what I was trying to get the whole time. So it could be very useful to help verify. All right, last thing we want to do here is we want to, this is like an ultimate problem. I really like these types of problems. And this is where we have two different things. We have sine of x. Remember, x is an angle, is 5/13. Cosine of y is an angle, negative 2/5. Now remember, they did tell us that x is in quadrant 2, right here. And they did tell us that y is in quadrant 3, right here. Now, what they want us to do is one of the things, we could ask you for a whole bunch of things. Now, I want you to practice what's on the worksheet, but I don't know if this is on the worksheet or not, to be honest with you. But let's say I wanted you to find sine of x plus y. Now, using the formula, that is sine of x cosine of y plus sine of y cosine of x. Now, I know some of these things. For example, I know what sine of x is. It's right there, 5/13. I know what cosine of y is. It's right there, negative 2/5. But I do not know sine of y. I do not know cosine of x. But I certainly can find them very, very easily. Let me demonstrate. Let me draw a picture of this angle x. Let me draw a quick picture of angle x. Here we go. Nice picture. Here's angle x right here. I know that sine is opposite over hypotenuse. And now all I got to do is find that missing side by doing, let's see here, 13 squared equals 5 squared plus a squared. Do the math. That's 169 minus 25 is 144 equals a squared. So I find out that the a value down here is 12. So I can now use this to find everything else. Or to find cosine of x, I could use the identities. I could use the fact that sine squared plus cosine squared equals 1. And I guarantee that you get 12/13 adjacent over hypotenuse. Now be careful. We are in quadrant 2, so cosine needs to be negative there. So that's, of course, always that thing you got to worry about, what quadrant you're in. Now over here, we're dealing with y. Let's draw a picture of it. Let's go ahead and draw a picture of y. Here's a nice, beautiful picture of y. And I know that cosine is adjacent over hypotenuse. So I could find that missing side here by going, let's see here, 5 squared equals 2 squared plus b squared. That's 25 equals 4 plus b squared. Let's subtract that. I get 21 equals b squared. Square root. I get that this missing side is the square root of 21. Believe that that is correct. Obviously, that didn't work out so nice, but hey, what are you going to do? If you also wanted to find sine of y, You could have used the identities, knowing that sine of y squared plus cosine of y squared equals 1. And you guess you would have gotten radical 21 over 2. But I'm in quadrant 3, and in quadrant 3, signs are negative. So anyway, let's come back to our formula here, and let's substitute everything in. Sine of x, 5/13. Cosine of y, negative 2/5. Plus sine of y. Hey, there it is. Here's y right here. I drew a little picture of it. Or you could use the identities if you prefer. Sine of y, radical 21 over 5. Don't forget it's negative because we're in quadrant 3. Negative radical 21 over 5 times cosine of x. So here we go. Here's a picture of x. Cosine, 12/13. We're in quadrant 2, so don't forget it's negative 12/13. Or you could have used the identities to find that. So here I get negative 10 over, let's see here, 13 times 5. I think I know what it is, but I don't want to say the wrong thing. 65. So I get negative 10 over 65. Plus, let's see, over here I get positive, let's see, I can't multiply those, but I could say 12 radical 21 over 65. Now, once again, I couldn't multiply them because the 12 was not in a square root, but I could do two negatives getting a positive. So I get negative 10 plus 12 radical 21 all divided by 65 because I did have a common denominator. Being that I have that radical there does make it a little bit tricky. But there you go. There's my answer. I was able to utilize the formula. I had to do a little bit of work to find some things. Now, I could find anything I want. If I wanted to do, think what I could do next. If I wanted to find cosine of x minus y. That would be cosine x, cosine y, plus sine x, sine y. And you know what? I've already done all the work to find all those things. So just fill in the blanks. Cosine of x, find it. Cosine of y, find it. Sine of x, find it. Sine of y, find it. Put it into the formula. It'll work out. Watch out if I would ask you to do something like secant of x plus y. Don't fret and say, well, there's no formula for secant. Don't worry about it. All you got to do is find the reciprocal. Remember, this would be 1 divided by cosine of x plus y. So what you would need to do is find cosine of x plus y first, using all of this information that we have located here, using the formula, cosine minus sine, sine. Use the formula and reciprocate it. Once you're done with the formula, just reverse it, reciprocate it, flip it over, and you will get secant. Don't worry about tangent as well. You got the tangent formulas, but again, whatever here, I could say, hey, what about tangent of x? Tangent of x, tangent of x, 5 over 12. Now I could use the tangent formula. I am in quadrant 2 though, so tangents are negative. How about over here? Tangent of y would be radical 21 over 2, but positive. In quadrant 3, tangents are positive. So now I could use the tangents to help me utilize the tangent formula. So hopefully all of that makes sense. If that all makes sense, then you're really much good to go. There is one more problem I want to do from your worksheet, and I'm saving it for last because it does take quite a bit of time to do. It is the verifying problem that is cosine of 3x equals 4 cosine cubed of x minus 3 cosine of x. Now let me demonstrate how I'm going to do this. I'm actually going to start with the left-hand side here and make it look like the right. And here's how I'm going to do it. I'm going to start off by splitting apart 3x to 2x plus x. Then I'm going to utilize the formula cosine of 2x, cosine of x, minus, because it does the opposite of what you think for cosine, sine of 2x, sine of x. But now I'm going to take this a step further, because I'm now going to break apart cosine of 2x to cosine of x plus x. Don't forget times the other cosine that was there. Minus sine of x plus x times sine of x that was there. So now I get using the formula here. Now watch, I'm going to do two things at once here. Be careful. Using the formula, I get cosine x minus sine x, sine x. Well, cosine x is cosine squared x minus sine squared x. And that's because they're both x. Can't do that if one was x and one was y, but they're both x, so I could do that. Notice I put in parentheses because I do have to multiply that by cosine of x. Back here, we've got to be careful. The formula works a little bit different for sine. It would be sine x cosine x plus sine x cosine x. it is repeated because, again, they're both x. Don't forget, you got to multiply by that sine of x that's out there. So let me clean things up a little bit here. First, I'm going to distribute. That gets me a cosine cubed of x minus a cosine of x times sine squared of x. Back here, watch this right here. This whole thing, notice they're both the same. They're both sine x, cosine x. So if I add them together, I get 2 of them. So I get 2 sine x, cosine x. And then I have to multiply that by sine, which creates 2 sine squared of x, cosine of x. Once again, in the parentheses here, sine x, cosine x plus sine x, cosine x, I added those together and got 2 sine x, cosine x. Then I multiplied by sine, which made the sine squared. Now, I notice my answer here does not have any signs, so I'm going to go ahead and I'm going to change the sine squareds to 1 minus cosine squareds. So I get cosine cubed of x minus cosine of x times 1 minus cosine squared of x minus 2 times, in parentheses, 1 minus cosine squared of x times cosine of x. And now I'm going to do some distribution here, and I should be finishing off the problem here very shortly. Distribute, I get negative cosine of x times 1 is negative cosine of x plus cosine of cubed x. Back here, I have to actually distribute the negative 2 and the cosine that's in the back. Okay, I could put an extra if I wanted to. I can just do one at a time. So that's going to be negative 2 times 1 times cosine is negative 2 cosine of x. Negative 2 times negative cosine squared is 2 cosine squared times cosine is positive 2 cosine cubed of x. Again, negative times negative made the positive 2 cosine squared times cosine made 2 cosine cubed. So now let me see. I got a cosine cubed, and 2 cosine cubed is 4 cosine cubes. Negative cosine, negative 2 cosine is negative 3 cosine of x, which is, of course, the answer I was looking for. So lots of fun there, but just another way that that formula can be utilized. So hopefully you guys understand the sum and difference formulas. Hopefully you were able to do enough of the worksheet to try the other problems. Some of those solving ones are good. Just when you do those solving ones, utilize the formula. It does take quite a bit of work. It looks really kind of messy at first, but a lot of things cancel, and it works out really, really nicely, believe it or not. So check those out. I will have the answer key done for you guys, but check out these formulas. They're pretty cool. And listen to some Kesha this weekend if you get a chance. She's pretty hot right now. All right, talk to you guys later. Thanks a lot.